Okay, dear students, we will start soon. We wait some host for Zoom conference, and after this we will start. Okay, wait a little bit.
जरूर भाई सर पोस्ट बना दो यार।
Repeat please. Okay, now we have possibility to start, and we will continue talking about enzyme and some PowerPoint presentation, which was in the lecture and today in the practical class will be available in Moodle platform now. Please, you can join the Moodle platform and check. Okay, and as you see in the screen, we can talk about some specific environment for enzyme, and some environment of enzyme will be connect with, for example, important situation with the important specific temperature, because temperature will be create or give a possibility to pass enzymatic reaction in specific conditions. For example, when we're talking about human body, most enzyme who work in the human body will be optimal temperature for this enzyme will be around normal human body temperature, around 36.6. Yeah, and also if you're talking about some enzymes of microorganisms who live in the hot springs, this enzyme will be work optimally in the, for example, temperature around 80 degree. Yeah, it's important because you must remember that it will be connect with, for example, a specific environment. Is a specific environment of organisms who live in this environment. For example, these organisms not can live in the very high temperature and very cold temperature. Yeah, and enzymes also not will work if you're talking about, for example, specific microorganisms which live in the hot springs. And same situation will be connect with, for example, pH. When we're talking about pH, we must remember the pH of enzyme, but optimal pH for working enzyme, it will be linked with specific condition of alive cells. For example, this some enzyme will work only in the pH of around cytoplasm of cells, human body cells. Yeah, but some enzyme will be work effectively with a more acidic condition and in the more basic condition. And this enzyme, for example, it will be ligation enzyme, and process of ligation will be linked with the change of pH. For example, in the our stomach, we can see specific pH, and this pH will be low pH, yeah? Will be acidic, and enzyme like pepsin will work only effectively mostly in this pH. Yeah. Okay. And what about other type of the decision? Other type of enzyme? It will be, for example, trypsin, and trypsin will work in more high pH, and this pH will be around 8 pH. Yeah, it's also important to remember. But I must emphasize again that most enzymes will be work effectively only in the pH, in the some middle pH, which can be linked with pH of cytoplasm of cells. Yeah. Okay. If you're talking about enzyme, we must talk not about only how enzyme work, and also important point for us will link with the how enzymes will be regulated by specific mechanism of regulation. For example, we can talk about how enzyme will be regulated by inhibition, some inhibitors, and by some activators. Yeah, it's also very important because enzyme can be regulated by some specific mechanisms of alive cells. It can be a competitive inhibition, and we can also talk about uncompetitive inhibition. Yeah, and for example, non-competitive inhibition. Non-competitive inhibition and uncompetitive inhibition, it will be different type. For example, non-competitive inhibition, it will be all type of inhibition added in one time, in one moment. Yeah, it will be connect with, for example, inhibition by competitive inhibition and uncompetitive inhibition together. If this two type of the inhibition present in the regulation of enzyme, concrete enzyme, this type of the inhibition will be named like a non-competitive inhibition. Yeah. What else we must remember? Also, we must remember that we can talk about allosteric inhibition and allosteric activation. As you remember, in the previous class, in the lecture class, we will start talking about allosteric inhibition and allosteric activation. And today we also will discussed a little bit about this type of the inhibition and activation. Yeah. And also we can talk about covalent modification, phosphorylation, for example. Covalent modification is most strong methods of regulation. Yeah. And these methods will be linked with the added or remove phosphate from the our for example, from our enzyme or from our protein. Yeah, and before we continue talking about methods of regulation of enzyme, we must also focus for specific methods of regulation. These methods of regulation will named negative feedback regulation. What it means? It means the final product of some cascade of chemical reaction can actively play important role for suppression of first stages for produce this final product. How it will look? You can see here example classical regulation procedures of some synthesis of some amino acid from precursors. Yeah, and as you see in the screen, these precursors will be synthesized from the aspartate, and aspartate in the first stages, in the beginning of this process, will be converted to aspartyl phosphate. It will be phosphorization. Yeah, and aspartyl phosphate will play important role for next stages of regulation. For example, it will be linked with the synthesis of lysine, synthesis of methionine, isoleucine, and threonine, for example, and some intermediates will be homoserine. And homoserine, lysine, and threonine play important role for regulate all this cascade of the reaction. For example, it will be negative regulation, negative methods of regulation, negative feedback for regulation, and in finally we will see decrease of synthesis activities of some enzyme like enzyme which can convert aspartate to aspartyl phosphate in this process, in this situation. When we're talking about competitive inhibition, it will be connect with, for example, specific inhibition like between it's like a competition between, for example, substrate and inhibitor. As substrate as an inhibitor can connect with, for example, active site of the enzyme, and after this connection, we will see, for example, inhibition if it's will connect with the inhibitor, and we will see, for example, also connection with the substrate. If we will talk about a specific substrate, specific reaction of this enzyme. Yeah, and what else we must add it here? We must remember that it's just a typical classic competition between inhibitor and substrate for specific active site of enzyme. Here you can see example of some specific inhibition by allosteric inhibitor. inhibitor, because allosteric inhibitor play important role for regulation, and during this regulation we can see, for example, some specific compound, which will be named like an allosteric inhibitor, which will be connect with a specific other side of enzyme. It's not will be connect with the active side of enzyme. It will be connect with the other side of enzyme. Yeah, and after this connection, we can see in final result that enzyme will change affinity with substrate. What's mean affinity of substrate? I think you remember, because in previous time we was talked about it. Affinity of enzyme substrate affinity will be linked with the, for example, how easily enzyme will be connect with the substrate. For example, if you're talking about high affinity, substrate will be easily connect with the enzyme. If you're talking about low affinity, it will be a reverse situation. It will be a situation when enzyme will be very easily find substrate and very slowly react to, for example, with substrate will be slowly react with enzyme. And when we're talking of, it's just repeat this slide, it's just repeat example which we talked before. And also we must remember that we can talk about allosteric activation. Allosteric activation, it's reverse situation. When we're talking about, for example, not when allosteric compound play role like an inhibitor. When we're talking about that allosteric compound play important role like an activator. Yeah, and in this reason, enzyme after this connection, enzyme will actively participate and change affinity to with the substrate, and this changing of affinity give possibility to increase of work of enzyme, not decrease, but increase, because activator it's not suppressor. Activator is just activator and give possibility to easily pass some chemical reaction and increase the activity of enzyme. Yeah. What else we must remember? It's just repeat of our topic. It's just repeat that how, for example, substrate and enzyme will change affinity if, for example, activator will add. Without activator, substrate enzyme interaction very poor and very ineffective, have a low effective, low productive interaction. But if regulator, if activator, allosteric activator will be added, affinity of enzyme substrate will be increased and productivity of enzyme will be increased. Yeah. And here you can see example of specific process which can be linked with, for example, phosphorylation of enzyme or some proteins. And phosphorylation of enzyme and some proteins give us chance to organize regulation more fixed, more strong regulation. For example, because if we're talking about competitive inhibition, it means that in every moment, inhibition can, a connection between inhibitor and enzyme can erupt, and enzyme can start work. Yes, it will be very easily to see how it's inhibitor will be like a jumper. It will be jump from the one side to the other side, and will change conform. Will give possibility turn on and turn off enzyme. It's this turn on of enzyme will be unstable, and turn off of enzyme will be unstable. Yeah, but if we're talking about, for example, phosphorylation, it will be more stable, fixed of turn on or turn off some enzyme. Yeah. Here we can talk about two additional enzymes. It's like a sub enzyme which play a role of regulator. It will be one enzyme which will play a role of, for example, of phosphorylate, and second enzyme, this enzyme will name like kinase. And second enzyme will play a role, important role for dephosphorylate. And name of this enzyme will be phosphatase. Yeah, phosphorylase and phosphatase is two enzymes who make reverse walk. For example, some walk will be focused to edit phosphate. This type of the enzyme will named like kinase, and second enzyme will play important role for remove phosphate. It will be phosphatase. And for this, for reason to understood this type of working of this enzyme, I recommend you come back to the Moodle platform, and in the Moodle platform you can find some additional information how the process of phosphorylation will pass and what kind of work this phosphorylation can make. Yeah. For example, as you see in the screen, we can see some videos, and I recommend you to focus in the first video, this one video. It will be video about enzyme kinetic, some animation, and in this animation you must to remember about the point that I will ask you about this animation. I will ask you about some points of how enzyme kinetic will, it will be question how enzyme kinetic can pass, and question for this video will be in the next our class. Okay, and also I recommend you find some information about kinetic in the, for example, what happened? Okay, just repeat. Okay, you can find the topic which will be linked with the enzyme. This one enzyme, you can find lecture and can look through what kind of discussion was around lecture. And here you can find some links to the presentation which we passed today. And here you can see some example of how phosphorylation is passed, what kind of work phosphorylation organized. For example, it's just video.
Cell, when it's ready, when it feels that everything is aligned and ready to go for the separation of the chromosomes, it is able to couple onto the growing and shrinking microtubules. It's transiently, it's involved with the growing of the microtubules, and it's able to transiently couple onto them. It's also a tension sensing system. It's able to feel when the cell is ready, when the chromosome is correctly positioned. It's turning green here because it feels that everything is just right. And you'll see that there's one little last bit that's still remaining red. And it's walked away down the microtubules. That is the signal broadcasting system sending out the stop signal, and it's walked away. I mean, it's that mechanical. It's molecular clockwork. This is how you work at the molecular scale. So with a little bit of molecular eye candy, we've got kinesins, which are the orange ones. They're little molecular courier molecules walking one way. And here are the dynein. They're carrying that broadcasting system, and they've got their long legs so they can step around obstacles and so on. So again, this is all derived accurately from the science. The problem is we can't show it to you any other way. Exploring at the frontier of science, at the frontier of human understanding, is mind-blowing. Discovering this stuff is certainly a pleasure.
Okay, I think more video you can find, you can see more details, you can see in the Moodle platform personally, and it will be part for task for second part of today class. Yeah, please not forget, you must be look through this video, and in the next practicum class I will ask you. But it's not necessary to look through all videos. I recommend you focus for your attention for first video about kinetics, enzyme kinetics. As a video, it will be like additional for your attention, for your interest. If you have possibilities or needs or interest, you can look through details in this video, and in finally recognize some points which will be which available now in the module in the video. Yeah. Okay. And what else we will do today? Today I want to check attendance now. And after checking attendance, we will focus. I will give you time for personal walk, for personal look through video during our video in our Moodle platform. Okay. Okay, be ready now for checking attendance. Okay, Razak, Abdul, are you here?
Yes, sir.
Good. Khalid, Berikah,
Barira Khalid, sir.
yeah. Okay. Nadim Roman. Nadim Roman.
Sir, yes, sir.
Good. Hayat Nimra. Okay. Hayat. Absent. Okay. Khan Muhammad Tasadik. Are you here?
Sir, I am here.
Good. Ahmad Manaf. Rasa.
Present.
Good.
Excuse me, sir. I am also present.
Who you?
Kiran Shahnaz.
Who you?
Kiran Shahnaz.
Kiran.
Yes, sir.
Kiran, wait, you will be later. Okay. Gulzar Fatima, are you here? Gulzar Fatima, are you here? Absent. Fatima Eman,
Present, sir.
good,
Attendance law.
good. Ahmad Zahur, are you here?
Yes, sir, present.
Good. Javed Hassan, are you here?
No, sir, he is absent.
Okay, absent. And Javed, sorry, Javed Hassan. And Fahar Muhammad Adil,
He is also absent, sir.
it's not in the course, yeah? And
Yeah.
Shahnaz Kiran.
Yes, sir.
Okay.
Yes, sir.
Okay, good. Okay, for today class finish.
Sir, Fatma Gulzar.
Yes, Fatima Gulzar, are you here?
Present, sir.
Yes, okay, I will change. Okay, dear students, our class not stop now. Now it's the second part of our work, and this second part will be linked with the task in the Moodle platform. Task in the Moodle platform will be connected to the loop through first video, and I will ask you your some question in the next practical class will be linked with this video. Please not forget about it, okay? Okay, then we will finalize our class and have a nice day.
Thank you, sir. Have a nice day.
Bye-bye.